Okay, so I'm going to continue our discussion on chapter 7 on rational expressions. So we stopped at C, so let's go on to D. And this is where we are looking at multiplication of rational expressions. So instead of looking at one rational expression, you now look at more than one. So let's write down the steps. And you might find them quite familiar. You are supposed to factor each numerator and denominator separately. Okay, and then you need to look for factor pairs to divide out. So remember what are factor pairs? Is either they are both plus or both minus. For example, a plus b and a plus b, that's 1. A minus b and a minus b, that's 1. A plus b and b plus a, they are not exactly the same, but addition is commutative, so that's again 1. The special pair to take note of is a minus b and b minus a. They're not the same, but the opposites. Okay, these two are opposites. So if they are opposites, then this actually becomes -1. And if it's 1 plus and 1 minus, remember you are stuck. Okay, so in multiplication of polynomials, so what you have, I'm sorry, not polynomials, rational expressions, you have PA over X and Q over X, and this time you're multiplying, say, R over X and S over X. Okay, so you have a whole bunch of polynomials, but you can look at Px and Rx as all in the numerator, just as you can look at Qx multiplied by Sx, all in the denominator. So we are back to equivalent to simplifying a rational expression. Okay, so it's back to what we learned in the last lecture. So that's why you notice the steps are very similar. You still factor each numerator and denominator, and you still look for pairs to divide out, and that's that. Okay, so let's try the examples. Let's try the first one. Okay, let's try the first example. 4x minus 12 over 6x cubed plus 24x squared multiplied by 4x squared plus 16x, and say at the bottom is let's try 9 minus x squared. Okay, so let's try this. So you notice, unlike the last lecture where we had only one rational expression to deal with, this time we have two. Okay, and later on you will see one that has 3. But the point is, you now have more to factor, so you're supposed to factor each one of them and write the result. So you have to factor each one. So for example, 4x minus 12, what can I do with that? I can take out a 4, leaving me with x minus 3. So that's the result, 4 times of x minus 3. What can I do with 6x cubed plus 24x squared? Okay, so I'm going down the list. My GCF is a 6, x squared, leaving me with x plus 4. So it's going to be 6x squared and x plus 4. And going to the next one, which is 4x squared plus 16x. My GCF is a 4 followed by an x, and so that's going to be x plus 4. So it's going to be 4x, x plus 4. Okay, and the last one, which is 9 minus x squared, that's a binomial and it's a perfect square, so it's going to be 3 plus x and 3 minus x. So let's write this down, 3 plus x and 3 minus x. Okay, so the hard work is done. Factoring, everything is factored, and these are all now factors. Okay, so you can put dots between them to remind you they are factors. And now you look for factor pairs. So the rule is, so long as you have one from the numerator and 1 from the denominator. It doesn't matter if it's crisscross or on top of each other, it doesn't matter. Okay, so x plus 4 and x plus 4, that's one pair. X minus 3 and 3 minus x, they're not exactly the same thing, but they're the special pair, okay, the one that's opposite. So negative 1, doesn't matter where you put the negative, it just means your answer will be negative at the end. Okay, now what else can I reduce? I could do the 4 and the 6, okay, and I can divide by 2. So that's a 2 and that's a 3. Remember, the 6 is not stuck to the x squared, okay, so they're really separate. And so now I'm looking at the x on this side and the x squared, so that's going to cancel, and that leaves me with an x. Okay, so I think we're done canceling. So let's see what do we have. We have a 2, we have a 4, and we have the 1. And these are all multiplied together, so the top is going to be an 8. As for the bottom, there's a 3 and there's an x, and there's a 3 plus x right there. So it's going to be 3x parentheses 3 plus x. And don't forget there's a minus, so my answer is going to be a negative. Okay, and that's that. Okay, let's try as a second example something that's much bigger. Let's see, 2a squared plus 5a minus 3 over a squared plus 2a minus 3. That's the first expression. Let's try a squared minus 6a plus 5 over a squared plus 2a minus 35. Okay, and let's try one more. Let's do the a squared minus 9a plus 14 over 2a squared minus 5a plus 2. There you have it. So what I've given you is 3 rational expressions to multiply, and so that means I have 6 polynomials to factor. Okay, so individually deal with it. You need to factor this, okay, and here too, and here too. Okay, so do the factoring, and okay, I'm gonna do it here so we can kind of do it together. So 2a squared plus 5a minus 3, I'm looking at a sum of 5 and a product of negative 6. That tells me I have to use positive 6 and negative 1, and to get a 2 is 2 and 1, so it's going to be 2a and 1a, and 2 is in charge of giving me the 6, so it's going to be plus 3, and 1 is in charge of giving me minus 1, so it's minus 1, so this is going to be 2a minus 1, a plus 3. Okay, let's do the next one. A squared plus 2a minus 3. The sum is 2 and the product is negative 3. So which two numbers will do the trick? Plus 3 with minus 1 will do it. So it's a plus 3, a minus 1. So a plus 3, a minus 1. Okay, let's go down the line. A squared minus 6a plus 5. Okay, the sum here is negative 6 and the product here is 5, so I have to use 5 and 1, minus on both, so it's a minus 5, a minus 1, so it's a minus 5, a minus 1. Okay, next one. A squared plus 2a minus 35. Sum is 2, product is negative 35. What times what gives me 35? It's going to be 7 and 5 plus 7 minus 5. So it's going to be a plus 7, a minus 5. So a plus 7, a minus 5. Okay, we're almost there. Let's go to the next one. A squared minus 9a plus 14. The sum I'm looking for is negative 9. The product I'm looking for is 14. Which two numbers will do the trick? 7 and 2 will do it. So that's how I get a minus 7 and a minus 2. Okay, and last one, 2a squared minus 5a plus 2. The sum is negative 5 and the product is 4. So 4 and 1 will do the trick, and minus on both. So 2 can give me 4 just as 1 can give me 1. So it's going to be 2a and a as in 1a. I need to get negative 4, so I need a negative 2 on this side. So that's where I get my negative 4 from. And 1 will match with minus 1. Okay, there you have it. So 6 polynomials to factor, and you factor each one. Okay, so it all depends on how fast you are with your factoring. Okay, so that's the hard part. So now let's do the cancellation. Let's see. What pair do you see? Okay, so the rule is 1 from the top, 1 from the bottom. So 2a minus 1 and 2a minus 1, that's one pair. Okay, that cancels to become 1. They cancel out. What else? What else? Okay, a plus 3 with a plus 3, that's one pair. Okay, that cancels out to be 1 again. What else do you see? Here, a minus 5, right? A minus 5, that's one pair. A minus 1 is one pair. Okay. What else? What else? A minus 2, that's one pair. Okay, what about a minus 7 and a plus 7? Now watch out. For them to be pairs, they have to be either both plus or both minus, okay? And plus and minus, remember, they are stuck, okay? So if you see one a plus and one minus, like in this case, a minus 7 and a plus 7, stuck. Alright, so everybody is cancelled out except the two of them. So what is the final answer to this question? It's going to be 1 times 1 times 1 times 1, and it's still 1. So what you have is a minus 7 for the top, and for the bottom is going to be a plus 7, and that's it. So remember, you're not allowed to touch terms, okay? So cancel out factor pairs, okay? Do not cancel terms. Very important, okay? So I keep reminding you. So that's why the 7s cannot touch, okay? And I've showed you this before, but let me show you one more time. If this was 3 minus 2 over 3 plus 2, for example, okay? If that's the case, you notice that the top is a 1 and the bottom is a 5, right? But you can't cancel the 2's and cancel the 3's and call it 0 or 1. Okay, so watch out for that. Okay, so no canceling. Watch out for that. Alright. Okay, so that's on multiplication. And since we're at this, might as well look at division. So the next thing you need to look at is division of rational expressions. Okay, and in division, do you remember, if you have a rational expression divided by another rational expression, for example, what you need to do is to convert division to multiplication, and at the same time you have to flip the fraction that comes after the division sign. Okay, so how should we say this? Convert, divide to multiply, and then you flip fraction after the division sign. So that's that's actually referring to the divisor, okay, the one behind, but it's the one that comes after the division sign. Okay, so in that sense, you turn a division problem into a multiplication of the reciprocal of the divisor. Okay, so what it means is keep the front fraction, change division to multiplication, okay, and at the same time flip the back one, so Sx goes to the top and Rx goes to the bottom. So when you do that, you're back to multiplication, and so the steps is exactly the same as multiplication, where you factor in numerator and denominator and then look for factor pairs. It's just that you have to do this extra step about flipping. So let's try one example, and then you can practice some yourself. Okay, let's try this. Okay, let's try this problem. Can you divide? Okay, and let's say you're given x cubed minus 27 over, say, x squared plus 3x plus 9 divided by, say, x minus 3. Let's try that. Okay. So remember, when you see x minus 3 by itself, it really means x minus 3 over 1. Okay, so you kind of have to know that it's kind of like over 1, just as when you see 5, it's 5 over 1. Okay, so when you see a term by itself, it really means over 1. So what happens is I'm going to turn the division problem into a multiplication of the reciprocal of the divisor. So that's why it became 1 over x minus 3. Okay, now remember you're not supposed to cancel terms, so we're going to have to factor each one. So the top is actually a cube. Let me do it here. X cubed minus 27, I'm supposed to look at it as x cubed minus 3 cubed. So little parentheses, big one. X minus 3 is the little one. The big one is where I go x squared, 3x, and 9. Remember the signs opposite and always plus. So this is going to read x minus 3 times x squared plus 3x plus 9. Now right underneath it, there's nothing I can do with that. X squared plus 3x plus 9 is not factorable, and neither is x minus 3. It's as simplified as I can get. Okay, as I won't be able to factor it, but that's okay. I can still cancel it because that's still a factor. Okay, that's exactly the same, so that cancels into 1. And x minus 3 and x minus 3, that cancels into 1 as well. So when everything is cancelled away, it doesn't mean it becomes 0. It's really a 1. 1 times 1 is still 1. Okay, so your final answer is 1. Okay, let's try another example. That's example 1. Let's try another example. Let's try this. Can we do, let's see, what do we want? Here, 3a squared minus 2a over 3a plus 2 divided by 2 minus 3a, and then multiply by, say, 3a minus 3 over 3a. Let's try that. Okay, now what you need to remember is you need to convert all the divisions to multiplication, and when you do that, you flip the fraction that comes after the division sign. So if you look at this problem right here, the only one that needs flipping is the one in the middle, okay, because he has a division sign in front of it, but not the last fraction, because the last fraction has a multiplication in front of it, and so that's fine. We want it in multiplication. So this is going to read 3a squared minus 2a over 3a plus 2 multiplied by 1 over 2 minus 3a. But I don't get to flip the last one, so it's 3a minus 3 over 3a. Okay, so the flipping is done. It's all in multiplication now. So let's see what we can do for factoring. So it's not that you always have to factor on the side, because some of them are not that much work involved. If you look at this, 3a squared minus 2a, I think you can see that the GCF is a, leaving me with 3a minus 2. The bottom I can't do much. 3a plus 2 multiplied by 1 over 2 minus 3a, I can't do much. This one, 3a minus 3, I can take out a GCF, right? 3 times of a minus 1. And this one is a 3a. Okay, so do we see a pair? Now watch out, 3a minus 2 and 3a plus 2, they're different, but 3a minus 2 and 2 minus 3a, they're opposites. So that's negative 1. What else? Okay, the 3 and the a, they're not stuck. Okay, watch out for that. So the 3 cancels with the 3. Okay, 3 divided by 3 is a 1, so if you like, you can put 1. And then this a can cancel with that a, and that's 1 too. I think as far as cancellation is concerned, that's it. So the answer is going to be negative in the numerator, is a minus 1, because 1 times 1 is still 1, so you have a minus 1 in the top, and at the bottom I have 3a plus 2, and I think that's it. Okay, so your turn to try some. So let me write down the page number. You will find these problems on page 313, and multiplication and division of rational expressions is found in section 7.3. Okay, so if you want to refer to your book, it's section 7.3. Let's see, the problems that I'd like you to try. Okay, let's get you to do 27, 37, 43, 49, 57, and 69. Have fun!